Let's talk about the motion of a charge in a magnetic field. So far, we've only talked about the magnetic force on a charge, but we haven't talked about how the charge actually moves through this B field. Recall that the magnetic force is Q times V cross B, and this force, as we learned, is always perpendicular to both V and B. And because of this, because of the fact that the force is always perpendicular, it can't change the magnitude of V, only its direction. So if at some certain time the force being perpendicular to V at some initial time, later it will still be perpendicular to V, the magnitude of V does not change, however its direction has. We've seen this kind of force before. It's a centripetal force, which causes an object to go around in circular motion. Recall that the centripetal acceleration is given by v squared divided by r, and using Newton's second law, we can write this acceleration as F equals mac equals mv squared over r, and substituting in for our value for the force, the magnetic force, we have it equal to qvb. The absolute value sign is here because we just want to know the magnitude. We can now solve for the radius to get r equal to mv over qb. And so we see from this equation that the faster the charge is going, the larger the circle we will have. And to make it go in a smaller circle, all we need to do is increase the magnetic field. Now there's a nice YouTube video of this, of electrons going in a magnetic field. When you watch the video, you'll see that initially the beam is undeflected. Here it's glowing because it's ionizing helium, so we can see the motion of the electrons. And as the B field is increased, the electrons start making a circular arc, and as it increases even more, that circular arc eventually becomes a full circle. This is a pretty cool video of what we've been talking about. A real live demonstration of a charged particle in a magnetic field is exhibited by the aurora borealis. Here we have high energy charged particles coming in from space, and as they get close to the Earth's magnetic field, at certain angles, they will start to circle around the magnetic field. Now they will have some initial velocity, so they will either travel, depending on their sign and direction, initial direction, to the North Pole or the South Pole. And because the magnetic field lines converge at both ends of at each pole, they will all get collected there. And then they hit the atmosphere and ionize the air, creating dazzling displays of light, as we see in this picture. This is taken in the North Pole, and it's also called the Northern Lights. For a really cool video, you should watch this one on YouTube. Okay, that's it. Goodbye.